Okay, well, good day, folks, and welcome to the Solar Show. In today's presentation, I'd like to discuss the offering from BlueNova called the Intelligent Energy Storage System. And really, I'd like to look at the value proposition that we have for you. Some really exciting developments on this front. I will show you how we can achieve significant cost reductions in your electricity bill in the commercial and industrial space. I can assure you that the products are immediately available. We're not talking about stuff that is going to happen in a year or two. We're talking about stuff that's happening already. And that these solutions of ours can last for a long time. We're talking 10, 15, even 20 years. So let's, and finally, I think we are prepared to offer guarantees on the results on the cost savings so that we are very confident that these systems that we are proposing here can lead to significant reduction in your operational expenses. So let's look at the situation that most commercial and industrial users are faced with in terms of electrical consumption. Annual tariff increases far exceeding the CPI growth rate. We're talking about 15% increase in electricity prices with CPI down at 3 to 4%. What we're seeing is that the direct kilowatt-hour consumption tariffs are going up by 15% per year. And we're also seeing that the demand charges are jumping even higher than that due to the fact that the utility would like to demotivate users to use power during the peak periods. We have continuous load shedding and uncertainty in the next couple of years on how load shedding will continue and how disruptive it will be to our organizations. We even have unscheduled interruptions, which is outside load shedding, also causing massive losses in operating your business, and loss in revenue, loss in profit. And then we have the inability to expand your electricity supply due to a lack of capacity on the network. And that is another big consideration that business is faced with. And of course, the continuous stress from management and from shareholders and stakeholders on how to reduce the cost of operating the business. So, talking electricity in the modern era, what are the possible solutions? Well, we all know that we can add solar. If you have rooftop, we can add solar PV to the roof. And then we can have a significant reduction while we're on grid of the direct energy consumption. We can also see that due to the fact that producing solar, which is in the region of, let's say, 1 Rand to 1 Rand 20 per kilowatt hour, that there is a significant cost saving due to the lower cost of energy of such systems. However, those benefits are only applicable for when the sun shines, and we all know that those benefits are really applicable during the time of the day when some of your peak demands are not present. There's obviously also tax benefit due to the incentives by the government to assist users and to promote the use of solar PV systems. The use of energy efficiency devices are well known. Clever ways of reducing energy with specialized inverter compressors, as well as low energy appliances like lights. These we've known about, and that is one way of reducing your expenses. The other way of surviving scheduled and unscheduled interruptions is the use of UPS systems together with generators. We all know that these UPS systems are quite expensive, especially for the little amount of time that they are used. And the running of the diesel could be as much as 8 Rand to 10 Rand per kilowatt hour, creating an additional expense during those load shedding periods. One clever way of reducing your demand and demand charges is to implement clever internal load shedding techniques and essentially moving your load to or outside the peak demand periods, resulting in reduced costs. And then the more promising and exciting opportunity, and that specifically I'd like to talk to you about today, is the energy arbitrage possibility. Essentially, this energy arbitrage opportunity is coming to the table due to the fact that the storage costs have come down significantly, and the fact that the municipalities and the utility is charging significant variances between the off-peak tariffs and the peak tariffs, and therein lies the arbitrage opportunity, i.e. one can purchase and store electricity when it's cheap and then use it when the tariffs are very high, and therein lies a big saving opportunity. So one of the big benefits of the arbitrage or the energy storage is that one can store energy at low cost and then also shave the peaks of your consumption, essentially reducing your peak demand peak demand of the plant. And then obviously during the peak periods, one can then discharge the storage elements in those slots. I'll show them when those slots are, and also reduce your bill by reducing your spend during the peak periods. One other technique is to adjust the power factor of the plant, and consequently reducing the peak demand of the plant as well. So in principle, the principle of the arbitrage is to, if one look at these two graphs, we have a low demand season graph, which is typically the summer periods. We have a high demand season tariff structure, and studying these tariff structures, one will observe that there's the periods marked in red, which are the peak tariff periods. During these peak tariff periods, which are typically 3 hours in the morning from about 6 to 9 or 7 to 10 in the summer, and again from 6 o'clock to 8 o'clock in the evening. During these periods, we see significant peak demand charges of, in this case, up to R3.28 per kilowatt hour. If you compare that to the periods which are marked in yellow, which is the standard peak periods, a reduction down from R3.28 to R1.01. That is a significant reduction in the cost between the peak and the standard period. But even more so, if one consider the areas marked in green, which are the so-called off-peak periods, one can see tariffs in the region of 56 cents per kilowatt hour. So one can purchase electricity at 56 cents for a certain acquisition cost, which is the cost of owning a storage device, and then discharge that during the peak periods. One can also do that during the standard period, which you purchase electricity at R1.01 in this case, and one can see that if you then use it during the peak period, that there's an arbitrage opportunity before the cost of the arbitrage machine of about R2.27. So between peak and off peak, R2.72 opportunity, and between the peak and the standard period, R2.27. So introducing the iESS, which is the device that is going to be used to essentially capitalize on this opportunity, one would have to quickly just zoom in and see what this device comprises of and how it's used, and ultimately how does it lead to the savings. So first of all, the iESS can be charged with multiple sources. In this picture, we see that we can use a PV array, we can use wind power from solar generation, wind generation, we can use a normal diesel generator, as well as the grid to charge the storage element. Then the discharge can be done into a residential application, commercial application, industrial, or even EV stations. Here in this presentation, we'll particularly look at discharging the storage element during the into commercial and industrial loads. Typical applications then, as I've mentioned before, we have peak shaving of trimming the demand, load shifting, which means we are moving energy consumption from the off-peak or standard peak periods into the peak by moving energy from those cheaper areas into the more expensive areas. We can also do voltage and frequency regulation. We can do a microgrid solution, which is an off-grid application. It's one of the other videos that we did at the solar show. One can go back and have a look at that. And then finally, the system offers inherent backup capability, which allows you to then use the system as a UPS system as well. This is a picture or two pictures of the same system deployed in Midrand. It's a 250 kilowatt by 1 megawatt hour energy storage system, and it's particularly designed to do load shifting and peak shaving, or demand management as it's known. The system is typically characterized to be a 6 meter or 12 meter containerized solution with a design life of more than 25 years. It comes in building blocks of 100, 250, and 500 kilowatt inverter systems. These systems obviously can be placed in parallel, allowing scalability up into the tens of megawatts and even hundreds of megawatt hours with the storage. The battery pack in a single container like this can be scaled from 140 kilowatt hours, which is fairly small, up to 1.5 megawatt hours in a single 6 meter isometric container. Looking a little bit more into the details of the system, we have an integrated battery management system, which is responsible to maintain safety and the health checks on all the systems and allows the system to protect itself if there's any unwanted conditions. There's an energy management system which manages the charge and discharge of the battery, and also it allows the energy optimization between the grid, the solar components, the diesel components, and other energy sources. The system comes with an integrated remote monitoring and management system, which allows complete off-site monitoring. We're running a 24/7 remote monitoring system that monitors all the alarm and warning conditions and allows essentially a preventative maintenance strategy while the consumer doesn't really have to worry about these items. It comes with a built-in thermal management system to make sure that all the components are running under optimal environmental and climatic conditions. We have an internal electrical distribution system that couples the AC component with the DC component in the two different chambers in the ICE unit, but also allows for the electrical interface to the AC distribution board, which is outside the system. System comes in with a built-in fire suppression system in both the AC and DC compartments, which makes it compliant to all the health and safety standards. We have a very sophisticated access control system, allowing very controlled access to what is a very valuable system. And I'll talk about it a little bit later, the system comes with a 10-year performance warranty, which is much more than just a workmanship warranty. So let's see how the load shifting and peak shaving actually works, when it is applicable, and how this leads to the required savings. So on this axis we have kVA, or the power requirement of load, and this is looking at it over a 24-hour period. And as an initial condition, we decided to cap the peak demand at 360 kVA during that day. So prior to the ICE system being in action, one can see that we have two places in the day where we exceed the threshold of 360 kVA. And obviously we would like to shave those peaks off and make the savings associated with those two peaks. But secondly, we have the two peak tariff periods, which in this case is scheduled between 6 and 9 in the morning, and again between 6 and 8 in the evening. And if you've seen on the arbitrage billing graphs, this is where the energy is almost, in some cases, 6 times the cost of energy at night, and as much as 3.5 times the cost of energy during the day. So one would certainly like to reduce the amount of energy usage from the grid during these two periods. So the principle of operation is quite simple. We would like to have a controlled discharge during these peak periods, and then also to ensure that the peak that one see here, just to the left of the second discharge period, that peak there, that is sort of preempting the peak tariff period, one would like to clip that peak as well. So that is the specific area that I'm talking about there. So if one implements the charge and discharge profiles as depicted by the yellow and blue lines at the bottom of the graph, one can then see the resultant energy demand from the grid, which is the green line. And one can see that during the peak, we are doing a controlled peak period, which is the first 3-hour period, we are doing a controlled discharge and also making sure that that peak around about, I think it's 8 o'clock in the morning, is also shaved off. Then we maintain the energy consumption below that peak. And then one can see that here before the 6 o'clock to 8 o'clock discharge, sort of from 5 in the afternoon, once we're also doing a controlled discharge and then continuing with that discharge from 6 to 8 in the evening. So sort of a hybrid result that we see in this picture of both peak shaving and load shifting happening simultaneously. And one would obviously want to optimize this for the maximum use of the energy storage device and controlling the total discharge for the day at 80% of the installed capacity of the iESS system. Okay, so let's just look at the levelized cost of energy of such a system. So a little bit of busy slide, but typically for a 500 kilowatt by 1.2 megawatt hour system on a full capital purchase is something in the region of 6.6 million rand. The system is guaranteed to deliver 4,600 cycles at 80% DOD, and during the charge period, one would expect about a 95% charge efficiency. During the discharge period, about 93, and that mainly comes from that very steep discharge during the last 2 hours of the daily arbitrage opportunity. We are only taking 230 days of the 365 days of the year in consideration here, and that's mainly because this business is a weekday business with school holidays and public holidays. So only working 230 out of the 365 days of the year, which significantly reduces the ROI compared to, for instance, a shopping center or a mall, which could have significantly more use out of the system. We are planning to finance the product over a 10-year period at a rate of roughly 9%. And what we find is that because of the government incentives, we have a tax shield of about 1.8 million, which can be claimed back, which results in a net finance required for the system of about 4.7 million. So if one looks at the sum of all the payments made over the 10-year period, that is a total of about 7.2 million rand that will have to be paid. And if one looks at the amount of energy that one can cycle per day, we're looking at about 1.7 megawatt hours. Those are the two controlled discharges at 80% DOD of this 1.2 megawatt hour storage device. So if you look at the total amount of kilowatt hours delivered in 10 years, it's about 3.9 million kilowatt hours, and that would then be at an average cost of about 2.17 Rand per kilowatt hour cycled. That's the average cost over the 10-year period. So if one looks at the bottom of the screen, just the finance calculation, the monthly repayment of roughly 60,000 Rand, calculated at 9% of the finance portion of 4.7 million over the 10-year period. That is what will have to be paid off. So what does it look like if one considers annual electricity increases? What does this 2.17 or 2.17 Rand per kilowatt hour look like over a 10-year period if there's escalation involved? Well, what it means is that the cost of ownership in the first year of owning the iESS is 1.26 Rand per kilowatt hour. So just imagine you've acquired one, you financed it, and you're cycling. So the cost of ownership of this device is in the region of 1.26 Rand per kilowatt hour. That escalates at 15% over the first 2 years, as we know that Eskom has settled the deal with NERSA, and then that will then further escalate roughly at 10% per year, giving you that average cost of 2.17 Rand per kilowatt hour. So let's look at the savings model. If one looks at the current total payment during the peak period over the 10-year period, the total expense of 22.5 million is coming your way. So if one looks at the 3 different options of charging the iESS system, then in the first option, we can charge the iESS with the off-peak tariff, and this will result in a roughly 3.9 million rands worth of savings for the morning discharge over the next 10 years. If the daytime charge is done with the excess PV and then discharged during the evening peak, there's an additional 6.9 million rand of savings because we consider the excess solar to be free of charge. However, if we charge the ICE with the standard tariffs during the day prior to the evening peak, there's an additional 2.14 million rand worth of savings. These savings are end user savings that are achieved after the channel partner has made his share on the ICE system. So, total savings over the 10-year period, off-peak and excess PV being charged with off-peak and excess PV, 10.8 million. And if you charge with off-peak and standard tariffs, which means that there's no PV involved, a total savings of roughly 6 million rand can be achieved. Let's talk about maintenance and support. So the system comes with a complete local and remote monitoring capability. It has extensive built-in test equipment which monitors all the parameters of the system. It can then send all the warning and alarm conditions back to the control center, as well as email, WhatsApp, or whatever form of communication is required to send that to the appropriate personnel. And we can also monitor the actual performance of the system, which means the charge efficiencies, discharge efficiencies, the total energy that is cycled, and can have a comprehensive overview of how the system is performed on a day-to-day basis. If one looks at the support and repair response that we're offering, basically what we're saying is that we will offer to hold spares in the countries that we will operate the system in. We appoint a local support agent, which will then perform scheduled maintenance on the system to ensure the uptime. And then we'll sign a service level agreement with our customers, which offers rapid response time and reduced mean time to repair. So really having a maintenance and support philosophy that is built around high resolution, detailed monitoring of the system and implementing a comprehensive spares holding and maintenance and support infrastructure. Let's talk about the warranty. BlueNova offers a 10-year performance warranty with the iESS, which means that we warrant not only the workmanship, but also we warrant the capacity retention of the system and the performance of the system under typical 3-hour charge scenarios, discharging at 3 to 4 hours, down to 80% depth of discharge. We guarantee an 80% capacity retention after 5,000 cycles with an operating environmental conditions of -10 to +60 degrees Celsius of ambient temperature. And what we're saying is that for more than 5,000 cycles, which is basically more than 13 years, we have a performance warranty on the system. Warranty response, that means if something goes wrong during the warranty period, as mentioned before, we're carrying in-country spares. We have spare components of all the lithium batteries, as well as the inverter, as well as the AC and DC distribution unit. So comprehensive spares holding on all the elements in the iESS. How do you get hold of one? Well, we're offering 3 options. The first one is an outright purchase by the end user. Second option is, in that case, BlueNova can assist with their financial partners to assist in the finance of the acquisition. The second model is where the end user and ourselves or our channel partners have a saving sharing model in certain ratios. And then the third one is a model whereby the customer can actually hire the system and then acquire it through a hire purchase model over a 7 or a 10-year period. Good. So in summary, for the commercial and industrial space application of the iESS system, we're very confident that we could offer significant cost reductions in the cost of energy and the usage of energy. The systems are available immediately. We carry stock of these items. We are producing more and more of them on a monthly basis. This is a long-term solution for your energy savings criteria. This is not going to go away overnight. And finally, the results are guaranteed. I thank you for joining us here at the Solar Show and listening to the iESS being presented to you. And please make a note of our contact details. And yeah, we hope to hear from you soon. Thank you very much.